As I had promised, that I'll be go through a demo of how blockchain really looks like. How does it function? So here's the link. You can go to the link, and I've already have it open. Let me go to the link, right? So before we go into what blockchain is, let me just give you an overview of what an hash is. So a hash is basically a mathematical value that is derived to for an arbitrary number of digits to get it back to a fixed length of value. What do you mean by that? So, for instance, let me just give you an example. Let me type a quick brown fox, right? Now, you see how this value keeps on changing as soon as this value keeps on changing as soon as I change each letter, right? Now, as you see, the number of letters is always fixed. It's always the same, right? And that's what hash function does. So with hash function, it's easy to verify that a particular value has a certain hash function, but it's very difficult to find out the actual value through its hash function. And that's how it helps in cryptography in blockchain and makes it really difficult for someone to actually find details of an individual transaction just through the hash function. They would need more details from it, right? So let me, I've done that. Let me put, if you see, this is hash function. If I put 1, it changes completely. 2, 3, 4, different, right? Now moving on how does this come to a block, right? Moving on, so here are the major elements of a block. One element that we are missing right now is the timestamp, but let's assume the timestamp of the system would be captured as part of when creating block. So this is just a demo, so let's take it as a demo. So block, you'll always have a number associated with the block. So this is block 1. There'll be nonce. I'll get to the nonce. This is hash function. So because there's no value, the hash function is this. In the Bitcoin world, it's really important to remember the first 4, 8, 16, and so on and so forth characters of hash value. Why is it important? Because that's how the Bitcoin blockchain algorithm works to create and how it makes it more competitive, more difficult for someone to actually mine for a block, right? So nonce is basically the value. The value that the system needs to calculate to get to a certain number of zero preceding zero as part of the hash function. So let me explain it to you easily. Let me put this value as 10. Right now, the initial block, as you can see, it changes color to green to red if new value, because this block is not in the chain yet. So we have to mine it and we have to put it to the chain. This is the value that's going into the chain. So let's do mine. We mine it. It's mining it. And it's been mined. I mean, this value, what mining did was, as you can see, there's been a change in the nonce. You had a different nonce previously. Now we have a different nonce. Basically, what the algorithm said is try to calculate a nonce so that the value of the hash has X number of preceding zeros, right? So in this case, it was 4 zeros. So calculate the hash of 10 such that the hash function, the hash value that's created through the hash function, which is SHA-256, has 4 preceding zeros, right? Now, if I change to 12, now you see it's red. That means the value hasn't been accepted. The hash function is such, and this is the nonce. Remember this nonce, and we'll mine again. So what the system does is tries to calculate the nonce so that the hash value contains 4 preceding 0. See, we got 4 preceding 0, and the new nonce is 64943. So that's what the system has to calculate. And that's what the calculation happens to actually create a block. As you could see, because it was when I clicked on mine, it took a few seconds. This is just one system, and just a simple implementation. Hence, it seems easy, but it's actually a very difficult task. And considering there are multiple systems fighting for the same resource, it's very very competitive. Now, moving on. Now that we understand hash, we understand block. Now, moving on to blockchain. It's a chain of blocks, right? So